Hello, everyone. Thank you for joining us. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, Apple Valley, California.
Science and Technology Channel.
You got it. There we go. Researchers at UC San Francisco have enabled a paralyzed man to control a robotic arm using a device that transmits signals from his brain to a computer. By simply imagining himself performing the actions, he was able to grasp, move, and drop objects. The device, known as a brain computer interface, functioned for a record 7 months without requiring adjustments. This might be the precursor to Cylons. It might be. Until now, such devices had only worked for a day or two. The study, which was founded by the National Institutes of Health, appears March 6th in Cell, the periodical Cell. Would you like to know more?
The BCI relies on an AI model that adapts to subtle changes in the brain as a person repeats a movement, or in this case, an imagined movement, gradually refining their ability to perform it. Quote, this blending of learning between humans and AI is the next phase for these brain-computer interfaces, says neurologist Kuranesh Ganguly, MD, PhD, a professor of neurology and a member of the UCSF Weill Institute of Neurosciences. Again, a quote, it's what we need to achieve sophisticated, lifelike function. So this is cool stuff.
Sounds promising.
Yeah.
The key was the discovery of how activity shifts in the brain day to day as a study participant repeatedly imagined making specific movements. Once the AI was programmed to account for those shifts, it worked for months at a time. Ganguly studied how patterns of brain activity in animals represent specific movements and saw that these representations changed day to day as the animal learned. He suspected the same thing was happening in humans, and that was why their BCIs so quickly lost the ability to recognize these patterns.
Ganguly and neurologist and neurology researcher Nikolish Natra, PhD, worked with a study participant who had been paralyzed by a stroke years earlier. He could not speak or move. He had tiny sensors implanted on the surface of his brain that could pick up brain activity when he imagined moving. To see whether his brain patterns changed over time, Ganguly asked the participant to imagine moving different parts of his body, like his hands, feet, or head. So, yeah, this is cool stuff.
Although he couldn't actually move, the participant's brain could still produce the signals for a movement when he imagined himself doing it. The BCI recorded the brain's representations of these movements through the sensors on his brain. Ganguly's team found that the shape of representations in the brain stayed the same, but their locations shifted slightly from day to day. Ganguly then asked the participant to imagine himself making simple movements with his fingers, hands, or thumbs over the course of 2 weeks, while the sensors recorded his brain activity to train the AI.
Hmm. Then the participant tried to control a robotic arm and hand, but the movements still weren't very precise. So Ganguly had the participant practice on a virtual robot arm that gave him feedback on the accuracy of his visualizations. Eventually, he got to the virtual arm to do what he wanted it to do. Once the participant began practicing with the real robot arm, it only took a few practice sessions for him to transfer his skills to the real world. That is just fascinating. So I'm envisioning somebody, let's say, that's paralyzed, right? They still have their limbs, but they're paralyzed. So could they somehow reconnect? Maybe not their, because it usually when you're paralyzed, it has something to do with your spinal column, right?
Right.
So
I don't
reconnect.
think so. Because, like you said, the spinal column, this guy had a stroke. So that's why he still had limbs working. He just couldn't make them work.
Okay, so let's just turn that around though. Let's say you have arms, but you can't make them work because your brain's not connected through the spinal column to make your legs work. So they implant they put rods in your legs, like a robotic rod, and then they hook you up with this chip or whatever it is, right? And then you start to be able to control it's like you're bypassing your spinal column and you're going to a robotic situation. I think they kind of already do that, right? Because they have these people that hook up in these things. We're maybe getting off topic here, but they're paralyzed and they're trying to learn how to walk again using like frames on the outsides of their legs or their arms or their back. Anyway,
Yeah,
but yeah,
it
I don't know.
supports their weight.
Yeah,
Well, I mean, this is a little bit off topic, but that's how Darth Maul survived. He was cut off at the waist, but he was still alive. If you watched in Star Wars Clone Wars, he had like legs attached to the bottom. They look like spider legs, like 6 legs or something. And then eventually he got 2 legs. But yeah, it might be possible.
yeah. Oh well.
Okay. Well, yeah, we'll keep an eye, definitely. He could make the robotic arm pick up blocks, turn them, and move them to new locations. He was even able to open a cabinet, take out a cup, and hold it up to a water dispenser. Months later, the participant was able to control the robotic arm after a 15-minute tune-up to adjust for how his movement representations had drifted since he had begun using the device. Ganguly is now refining the AI models to make the robotic arm move faster and more smoothly, and planning to test the BCI in a home environment.
All right. For people with paralysis, the ability to feed themselves or get a drink of water would be life-changing. Ganguly thinks this is within reach. I'm very confident that we've learned how to build the system now and that we can make this work, he said. The study was funded by the National Institute of Health and the UCSF Weill Institute of Neurosciences. So, yeah, cool stuff. So, yeah, they are working.
Okay, I get this now. I understand now. You just
Yeah.
put the robotic stuff on the body, and the brain controls the robotic, arms and legs.
Right.
Yeah,
Right.
I can see it. Yeah.
So it's like you're
Eventually, you would just need your brain. You wouldn't need your body.
well, yeah, or just some way to move the body. Like you said, either put it on the outside of the body or insert like a rod or something inside the leg. Because again, there's no feelings. I used to work with a guy, and he was paralyzed from from the waist down after a motorcycle accident, and he had no feeling. I mean, we went on a business trip one time, and he cut his side, and he was bleeding. And I said, "Hey, man, you're bleeding." He goes, "I don't know, can't tell, couldn't tell." So that would be cool if they could hook up some kind of a robot arm or leg or whatever to these paralyzed limbs, and I mean even your back, right? And you could move again. I mean, that would just be game changing, amazing. So cool story. Go, Dr. Ganguly.
It'd be like strapping into this big robot, and it works for you.
Right.
Yeah. All right. Thanks a lot, folks.
Take care, everyone. Thank you.